Okay, hello, homework time again. If you didn't find the old videos on how to do this, here's some new video with some slightly better quality and less children in the background. We're just gonna pick some questions here and answer them to the best of our ability. Alright, so let's start with one that looks like 5 red marbles and 10 blue marbles. And the question says, if you randomly pick one, what's the probability of getting 2 red? And this says without replacing. Okay? So really what we're looking for is the probability of, is it both red? Yeah, 2 red. So we want red, then red. Okay? So the first time we pick red, there's 5 to choose from, so that would be 5 out of a total here of 15. And then the second time, there's not 5 red anymore because we took 1 out, which means there would only be 4 remaining. So that would be 4 out of a new total. It's not 15 because again we took 1 away, so 4 and 10 makes 14. Okay, then we simplify. So 5/15 we know is 1/3. 4/14 we can say is 2/7. And then we just multiply this out. 1 times 2 is 2. 3 times 7 is 21. A little bit less than 10%. And there's your answer. That wasn't so bad. Alright, let's do some more probability stuff. So it says, a number cube has 6 faces and Mr. Velez. He made a little chart here and it said number and frequency. So it was numbered like a regular old cube. 1, 2, 3, 4, 5, and 6. And the frequencies he got were 6, 8, 9, 8, 9, 10. So that's his table. And what's the question? What is the percentage difference between the experimental probability and theoretical probability in terms of rolling on odd numbers? We're only concerned about getting an odd number. Okay? So theoretical, that's what should happen. So what should happen? So what is the probability theoretically of getting an odd number? Well, we'd say on a cube we have a 1, a 3, and a 5 are all odd. Right? So that is 3 out of a total of 6 outcomes. And 3 6s 1/2. And then this one, it specifies percentage difference, so we need to know what the percent is here. So 1/2 just happens to be 50%. So theoretically speaking, the probability of getting an odd number is 50%. Okay, that's cool. Then it wants to know the difference between that and the experimental. So we said experimental probability is what does happen, what actually occurs. And in order to have experimental probability, you have to have an experiment. You have to collect data, such as Mr. Velez did for us. So in this case, we look at how many times he actually rolled an odd number. So he rolled a 1 6 times, he rolled a 3 9 times, and he rolled a 5 9 times. So how many times did he roll an odd number? This is 15 plus 9. That's 24 times he got an odd number out of the total here. And the total said was 50. And if we add these 17 and 7, yeah, that adds up. So this is 24 out of 50. Alright. Now, to turn this into a percent, we could do a couple things. We could simplify this. Get 12 out of 25 and then we could divide it top in, bottom out, and this would give us, well, 25 can't go into 12, so we add a decimal and a decimal, a couple of zeros here. And this would be 4 and 100 and then 200. This goes in 8 times. So we get 0.48, and then we'd say move it over a couple times, dp, get 48%. Right? And this will work no matter what the fraction is. Right? Dividing will always get you there. Fraction to decimal, decimal to percent. Okay? But we have other options here. Since we're talking about percents, we can say, actually let me erase this here. I'll leave the answer because that's correct. No point erasing correct answers. Percents is always some fraction out of 100, right? So what is this number? And the reason why I say to do it like this is because if our denominator is 50, it's not difficult to see how to get from 50 to 100 because this is just times 2, which means we can take our numerator and do times 2, and then 24 times 2 is, guess what, 48%. Okay? So this isn't always the best idea, like if our number was, I don't know, 17/39. It's not quite as obvious to see how to get from 39 to 100, so this method isn't incredibly efficient over TIBO and then decimal to percent, but you could do it. You could solve the proportion, cross multiply. But sometimes they try to make it easy for you, and they give you a denominator that can go to 100 pretty quickly, or pretty painlessly. Okay, and that's what happened here. So now we can answer the question, the difference between this and this. And difference just means subtract. So 50 minus 48 is 2%. Okay, and we can say that the experimental is 2% less than the theoretical, because it came out less often than you would have expected it to. Which means, conversely, that the probability of getting an even number would have been 52% and more. Happened more than it would have been expected to. But you don't need to know that. Okay, moving on. Number 3, which is not number 3 on your paper, but it's okay. So it says the Stevens going on vacation, and they saved $4,400. Okay, and then they plan to spend $1,200 of that to fly. That just says travel, but I'm going to assume they're flying. And then they spend $80 per day, you know, buying lobsters and jet skis and whatever else they're doing. And it says, write an inequality to describe this situation. So inequality, what that means is instead of saying, example-wise, instead of saying 3 plus 2 equals 5, this is an equation, right? Because these left and right sides are equal, but we want an inequality, which means we want to say 3 plus, I don't know, w. Oh, excuse me. We want that to be greater than 5. And we want to know everything possible that will make this situation true. So, like, w would have to be some number higher than 2 to make this sum greater than 5. Okay, that's our goal, inequality. Okay, so we consider what they have to spend and what they're going to spend it on, and we're going to put them on opposite sides of our inequality. So we're going to say $4,400. That's all the money they can spend. Okay, and then on the other side, the money they did spend, so they spent $1,200. They spent that one time, and that's it. They also spent this, so we'd say plus, and then $80 per day. So like for one day, that would be 80 times 1 is 80. If it was 2 days, it'd be 80 times 2, and that's 160. But we don't care about a specific number because we want to know for anything So we say 80 times whatever number of days is 80 times whatever that number is. Okay, so this is what we're going to put our inequality. So I'm going to get rid of my notes here. Make this nice and clean. So this is 80 times d. All right. So now we have it. We have everything except for our sign in the middle here. So this is money available, and this is money spent. And now the question is, are we going to put less than or greater than? Let's leave it at that. We could also say less than or equal to or greater than or equal to, but let's just do these two because I don't think we ever talked about greater than or equal to, and that's not going to be a huge deal for us right now. So if we think about this, if you're going on vacation, what has to be the higher amount to be a successful vacation goer that's not going to be stuck because they ran out of money? Can you spend more than you have, or does what you have to be more than what you spend? And hopefully the obvious answer is that this has to be the bigger number. You cannot spend more than you have. So in order for this to work, we have to say $4,400 has to be greater than whatever amount of money they spend. Okay? And now we could go in and actually solve for D, but that's not what it's really asking for here. So this is a satisfactory answer. And then we could make it slightly more satisfactory if we consider, could they spend exactly $4,400 and still be okay? Technically speaking, yes. Yes, they could. So we could say this is greater than or equal to. And that's what this sign means. Okay, that was fun. Let's go again. How are we doing on time? 12 minutes. Ah, okay. That's pretty good. So let's see. Scale factor, two similar polygons is 3 to 4. Perimeter of the larger polygon is 200. P equals 200. We want to know what is the perimeter of the smaller polygon. Okay. So it says polygons. This could have been, a triangle, or it could have been an octagon, or it could have been anything. But so we're just going to keep it simple. We're just going to say it's a good old rectangle. So then it says our scale factor is 3/4. So SF equals 3 to 4. And I don't really like this because we never really talked about scale factor in terms of ratios. So why don't I just say this is 3/4? I like that better. It's the same number. It's still just another way of expressing a ratio. But I'm used to seeing fractions. So I like this. Alright? So now how do I find my new perimeter? I say, oh, this is a scale factor question. Anytime we're doing scale factor, we go to our house, our scale factor house, and it has 3 floors on it, right? And one is perimeter, that's the first floor, and then area on the second, and then volume up top. And this is all based off of relative number of dimensions. So in this case, we're on perimeter. We're on the first floor, which means this is going to be super easy. Okay, no matter what floor of the house we're on, our formula looks like that the new whatever, in this case perimeter, is equal to the original whatever, again in this case perimeter, times, spelled scale factor wrong, times SF, and then this is raised to some power, which is the same as the floor we're on, but we're perimeter, that's just one dimension, so this is just to the first power, or just scale factor. I don't even need to put the exponent there. Okay? And now all we got to do is put in our information. We put in what we know. So I know this perimeter this perimeter. Oh man, this is where it's going to get a little tricky because it doesn't say which one's the new one. But we can say if our shape is getting smaller, right? Because 3/4 is less than 1. And if we said the scale factor is less than 1, gets smaller. And then conversely, if scale factor is greater than 1, it gets bigger, right? So if we think our second shape is the smaller one, so is this 200 the new or the original? And you would say, well, this has to be the original because the new one is going to be smaller than that, which means I kind of made a mistake here because usually when we do these scale factor questions, I like to put the new shape on the right side. But now we're okay. Assuming I read this correctly. Yes, we're good. Okay. So that's our original times our scale factor is 3/4. And that's going to be our new. And then this is super straightforward. We just have to multiply across. So we can turn 200 into a fraction. And then we can simplify 204. I can divide both these by 4 and get 1 over here, 50 down there. Okay, and then 50 times 3 is 150. 1 times 1 is just 1, so I'm not even going to bother putting that. And I know that my littler shape is going to have a perimeter of 150. Okay. Okay. That's not so bad. And that's centimeters. Okay. So these scale factor ones, remember your house. Because you have to remember it. And you also have to remember this part here. So this whole thing is kind of important. Sort of makes me wonder why I drew all over it. So this is not on your chart. Okay? So you have to remember this. New is original times scale factor to the number of dimensions. Right? Okay. So let's look at another one. Point R, our pirate point, is at -5, 4. And then what would it be if we translated it x plus 3, y minus 4? Now this one sounds like stupidly complicated because I'm like, what is all this noise? But really, this is about as simple as it gets. Any coordinate, point any, the coordinates will always look like x, comma, y. Okay? And your translation rule will always just be x plus or minus something, comma, y plus or minus something. And then x and y is just x and y. So in this case, we just say x is going to be -5, y is going to be 4, and then everything else stays the same. So this is plus 3, comma, minus 4. Then you do some basic math. -5 plus 3 is -2. 4 minus 4 is nothing. So our new point R, or as we refer to it, R prime, roll out, is -2, 0. And that's it. That's all there is to it. We can confirm this with a terrible little grid here. We have -5, +4. This is R. We say x plus 3, which means x is moving to the right. It's getting bigger 3 places. So 1, 2, 3. Oops. Oh, I don't want to actually put the point there. Just want to casually pause there for a second. And then y minus 4, which means y is going down. It's getting smaller. So we're going to go down 1, 2, 3, 4. And we end up at our new coordinates, which looks an awful lot like -2, 0. So hooray for that. So don't get thrown off by the translating. 2 ways you can do it. You can do the basic calculating, or you can find yourself a grid somewhere And when you're taking the actual STAAR test, there will be a whole big old graph paper page you can tear out of your book, and you're going to tear out of your book, and you can plot these points, and you can do +3 and -4 and get this answer. So do that. Do that. Okay. We got time for one more. Let's do a good one here. I like this one. Find the 5th and 7th term. I tell you I have an Instagram. I want like 1 million followers on Instagram, even though I don't like Instagram. But it seems to be what the kids are all about these days. So I'm either going to get super popular or I'm going to make kids hate Instagram. And either way I win. So be sure to like the real Mr. LS. And then there's a little video telling you to watch this on there, right? And then you comment on there saying like hashtag 6th period and saying why your class is no wait I got something better. I was thinking about this. Okay, hashtag your class period and then what you want to do tomorrow in math class, right? And I'm going to take the best suggestion, if there is one. I might just get a bunch of terrible ones and I'll just do whatever I feel like. I'll take the best suggestion and we'll do that tomorrow. Okay? So find me. And then less than 3 my video telling you everyone else to watch this, and then tell your friends, and then leave comments, all in the name of math. Okay, what were we doing? Oh, this question. Find the 5th and 7th term of this mess right here. And you think, oh, this is awful. What do I do with this? If you're finding the 5th term, the 5th term means n is 5. So we take our little expression here, and anywhere we see an n, I'm just going to replace it with the number 5. Okay, so -5 times 5 minus 5 squared minus 5. We got a bunch of 5s. That's not so bad. So -5 times 5 is -25. We do the parentheses over here. So 5 squared is 25. Probably should have done this first. Whoops. Oh well. It's going to work out the same. 25 minus 5 is 20. So we have -25 minus 20, and we don't freak out here. We change this into a nice addition problem for ourselves. We say -25 plus -20 more. That is a grand total of -45. So what is the value of the 5th term? -45. Okay. Let's take all this good work and put it over here. So now we're going to do the same thing again, except now instead of n being 5, n is going to be 7. So we do the same thing. So -5 times 7 minus 7 squared minus 7. Then we just work it out. Let's actually do the parentheses first, so I make it seem like I'm listening to my Aunt Sally. This is 49 minus 7, which is 42. So minus 5 times 7. We'll just bring this down. So -5 times 7 is -35 minus 42 more. Okay. And this gives us, again, I don't really want to mess with subtracting. So I'm going to say -35 plus -42. So again, I'm just combining those. So 35 and 42 makes 77. Since they were both negative, it's going to stay negative. Oh man, that's stretched on a while. Okay, but I want to do one more thing, because this is awful. I don't know why they would give you this. And some of my classes would be able to make this look better. So let's see how we can improve this equation. So let's say I want to distribute out, I want to get rid of these parentheses. I don't like them. So I'm going to distribute my -1 here. So I'm going to say -5n minus n squared. And then negative 1 times negative n is actually just going to be positive n, right? And then I can combine my like terms. So negative 5n plus n is negative 4n minus n squared. That's pretty good. That's pretty good. We can do this better though. Let's then factor some stuff out. That could be fun. Let's see what that gives us. So let's take out the negative 1 and the n. So let's factor out negative n. And then let's put this n squared first. It's going to be n. Right? Because negative n times n is negative n squared. That's that. Negative n times what is negative 4n? That's just plus. Ooh, not 5. Not 5, but 4. See? That looks a lot better. Negative n times n plus 4. And let's try it. See if I've gone crazy and forgot how to do basic algebra. So let's take our n equals 7 example. So negative 7 times 7 plus 4. That's negative 7 times 11. And oh my goodness, get the same answer. So, yeah. You don't have to do that, but this is inexcusable. I wouldn't take this as an answer to any sort of expression. This is much better. I'd even take this, although, you know, putting them in the correct order of degrees would be nice. So negative n squared minus 4n. That looks much better than this catastrophe. Alright, you know what your homework is, so get it done and have fun doing math. Okay, good night.